Imagine a robot that instantly understands you, perceives the world as you do, and effortlessly manipulates objects it's never encountered before, without requiring any prior training or programming. That's precisely what Figure's new Helix AI is bringing to life, and it could be the most significant advancement in home robotics yet. A few weeks back, Figure announced it had ended its partnership with OpenAI. The company's founder, Brett Adcock, took to Twitter on February 4th to explain that Figure had made a groundbreaking internal breakthrough in fully autonomous AI for robotics. That breakthrough was later revealed to be Helix. Following this announcement, reports emerged that Figure was in talks to secure a massive funding round, $1.5 billion, bringing its valuation to an astonishing $39.5 billion. This level of investment suggests that investors have seen something truly impressive, likely getting a first-hand look at Helix's capabilities. So, what makes Helix so revolutionary? The name itself, Vision, Language, Action, hints at how it seamlessly integrates three critical components, allowing robots to interpret their surroundings, understand commands naturally, and take action in real time. If successful, this could be the key to creating robots that can assist in everyday tasks, from putting away groceries to handling complex household chores, making life significantly easier. Helix AI is built on a generalist model, meaning it's not designed for just one specific task. It can handle thousands of household objects without needing extensive training for each new item. Figure has developed a system that allows robots to see their surroundings, vision, understand commands, language, and take action accordingly, action. Unlike traditional robots that require detailed programming and massive datasets for every new object, Helix adapts in real time. In one demo, two robots were simply asked to put away a bag of groceries. They scanned the kitchen, opened the fridge, placed items inside, and even knew to put an apple in the fruit bowl, all without explicit instructions. What's even more impressive is that these robots worked together seamlessly, passing items back and forth without any issues. According to Figure's founder, Brett Adcock, they've been refining Helix for over a year with the goal of creating truly general robotics, machines that don't just follow preset rules but can think, reason, and respond to voice prompts like humans. This is a major breakthrough in robotics, especially because real homes aren't like factory floors. Things are constantly moving, lighting changes, and every space is different. Helix is designed to function in that unpredictable, messy reality, bringing us one step closer to practical household robots. For a robot to truly function in a home environment, it needs a level of adaptability that has long been missing in robotics. One of Helix's biggest innovations is its dual system approach, which Figure calls System 2, S2, and System 1, S1. S2 is the slower, high-level reasoning system, a pre-trained vision language model that understands natural language commands, analyzes the environment, and develops a general plan. S1 is the fast, real-time motor control system, executing physical actions at an impressive 200 Hz, 200 updates per second. Think of S2 as the brain. It takes a step back, processes information, and figures out what needs to be done. S1 acts like the nervous system, instantly translating that plan into precise movements. Unlike previous AI models that either excelled at reasoning but were too slow for real-world interaction, or were fast but limited to very specific tasks, Helix combines both in a way that works efficiently. Plus, it runs directly on low-power GPUs inside the robot, meaning no need for an external computer, making it practical and ready for commercial use from day one. By dividing Helix into S2 for slow, thoughtful reasoning and S1 for fast, real-time execution, Figure has managed to create a system that balances intelligence and speed. To train it, they built a dataset with 500 hours of teleoperated behaviors and used an automated language model to generate natural language instructions. This means each demonstration aligns with how a human might naturally describe a task, making it more intuitive. But Helix isn't just fast and smart. It also introduces several groundbreaking firsts in robotics. Full upper body control. The robot has 35 degrees of freedom, meaning it can move its wrists, torso, head, and fingers in a highly coordinated way, all at 200 Hz. This is crucial for handling complex tasks, like picking up objects of different shapes and weights or twisting its torso to look inside a fridge while opening the door. Multi-robot collaboration. In a demo, two humanoid robots work together to pass grocery items to each other based solely on verbal commands. For example, when instructed to pass the bag of cookies to the robot on your right, both robots understood their surroundings and executed a smooth handoff. Pick up anything emergence. Unlike traditional robots that need extensive training for each object, Helix can recognize and interact with thousands of new items on the fly. If you tell it, pick up that weird plastic dinosaur, it can understand what you're referring to, even if it's never seen that object before, by combining language comprehension with visual processing. This ability to adapt without pre-training is a game changer, bringing us closer to truly versatile home robots that can function in dynamic, everyday environments. One of the standout features of Helix is its unified neural network approach. Instead of using separate modules for different tasks, Helix relies on a single integrated system to handle everything. S2, the reasoning model, is a 7 billion parameter vision language model, responsible for understanding commands and planning tasks. S1, the control model, is a smaller 80 million parameter transformer, designed for executing movements in real time. This means Helix doesn't need fine-tuning for every new task. It can handle a wide range of actions like picking up objects, opening drawers, placing items, and even passing things between robots with the same neural network. Another major advantage? Helix is commercially ready. It runs directly on embedded GPUs, so there's no need for a massive external server or cloud processing. This makes it faster, more secure, and truly mobile. The robot can move around the house freely without being tethered to a bulky machine or relying on an internet connection. Plus, no cloud dependency means no random lag or downtime if your Wi-Fi cuts out, making the system far more reliable. And right now, everything with Helix is still in the early stages. The demo videos from Figure make everything look smooth, but it's safe to assume that behind the scenes there's been a ton of testing and fine-tuning to get those results. Realistically, we're still a few years away from robots seamlessly cooking full meals, folding laundry, or vacuuming the house like a human would. However, Figure is positioning Helix as a game changer, one that can scale from industrial applications, where they're already working with automotive companies like BMW, to actual home use. Meanwhile, the race for humanoid robotics is heating up. Meta is reportedly creating a new AI-powered robotics division. A startup called Aptronic just raised $350 million with backing from Google DeepMind, and there are even rumors that Apple might be entering the field. As TechCrunch's Brian Heater pointed out, most companies developing humanoid robots are focusing first on industrial and logistics applications before bringing them into homes. With so many major players jumping in, we're looking at a full-blown robotics arms race to shape the future of humanoid automation. Most humanoid robots start with moving boxes in warehouses because factory environments are structured and predictable. But Figure is betting big on home robotics, which is far more challenging. Homes are full of unpredictability. Furniture gets moved, liquids spill, laundry piles up, and people leave things in random places. If a robot can handle that level of chaos, it automatically solves a major piece of the puzzle for general-use robotics. That said, Figure isn't abandoning industrial applications. Instead, they see the home as the ultimate test of adaptability. If a robot can navigate the messy, ever-changing world of a household, then tackling structured industrial tasks should be a breeze. The idea of bridging the gap between factory floors and living rooms has been discussed for years, but few have pulled it off because the technical challenges are so different. Traditional approaches required either manually coding every action or training robots on thousands of nearly identical demonstrations. Helix bypasses that outdated method by using a vision language model that gives it a common-sense understanding of the world. Instead of needing endless training for each new task, it can interpret its surroundings and act accordingly, a crucial step toward truly useful home robots. Helix learns general concepts about the world, like how a fridge door opens or where apples are usually stored in a kitchen. Then, S1 handles the finer details, allowing the robot to adjust its grip and movements without needing hours of retraining every time it encounters a new mug, toy, or household item. This kind of approach could be a major leap in robotic capabilities, as Figure's founder Brett Adcock has pointed out. Of course, there are still big questions about safety, reliability, and even cybersecurity. One major concern? Could a home robot be hacked and controlled remotely to do something unintended? While we don't have all the answers yet, this is an issue that will likely gain more attention as the technology advances. For now, Figure is laser-focused on perfecting the core AI, ensuring that Helix can quickly adapt, generalize, and handle real-world tasks on the fly. There's also a big emphasis on user-friendly features, like natural voice commands to make interacting with the robot as seamless as possible. Helix is built as a single unified system that can handle objects it's never seen before and even allows multiple robots to collaborate in real time. According to Figure, it's designed to function much like a human. It can understand speech, reason through tasks, and physically interact with objects on demand. Of course, not everyone is ready to welcome a six-figure humanoid robot into their home just yet. But as mass production ramps up and costs hopefully decrease, we could start seeing these robots in service industries, elder care, or even as high-tech household assistants. So what do you think? Would you trust a humanoid robot to navigate your kitchen? Or do you think we should wait until the technology is more advanced, and hopefully more affordable, before letting a machine grab a glass from your cupboard? Drop your thoughts in the comments, and as always, thanks for watching. See you in the next one. See you.